78 we have, did I write 74 on that one? Yes, I did. Okay, in 78 we have r equals 3 meters, we have theta equals 120 degrees, and they're asking us to find the length, the arc length. Okay, perfect. Immediately I have to change this into radians. But I know that 120 is 2 of pi over 3. Very easy. Yes, you can change it with the formula. Which formula? This one. Pi equals 180. 1 degree is pi over 180, and then simplify. Or you say, oh, 120, very easy. 2 of 60. Now I can write the formula, which is r times theta. So S equals r, which is 3, multiplied by 2 pi over 3. Simplify. Do not continue. This is an equation. S equals 2 pi, and I have to write the measurement unit. Always write the measurement unit. This is not an angle. This is a length. Now, if you want to approximate, you will multiply, let me write it on the side here. You will multiply 2 by 3.14, and you will approximate it at 6.28. Okay? Perfect. Do we want to work on anything else? Or we continue with the arc length? We do have a word problem. We're going to work on this word problem in a minute, 108. But let's see if we want to look at anything else. Is that a yes? Is that a no?
We do 76.
Okay, very good. So let's also look at 76. In 76, we have r equals 6 meters. We have S equals 8 meters. And this time, they're asking us to find theta. And theta will be in radians. Mandatory. Careful. So we have that S equals r theta. From here, I can solve, or I can plug it in first. 8 equals 6 times theta. And how do I get theta? I know it's a silly question for you, but I'm asking it anyway. How do I get theta?
Divide by 6.
Very good. So 8 over 6. And I will divide. I'll simplify by 2. And I get 4/3. Of course, it has to be radians. And I don't want to approximate it. Or first of all, we can actually write it as 1.33 radians. Yes, there is no need to write radians. If we say theta equals 1.33 or 4/3, there is no need, because there is no bubble or circle that says otherwise. If it doesn't say otherwise, it has to be radians. Good. So let's, any questions? Anyone? Okay, on page 8. So we wanted to look at the circular, let me see, where is my book here? Here it is. Where are you guys? When I open so many different windows, I lose you. So I selected, and you can select anything you want, but I selected 81, 83, and 89. If you prefer something else, please speak up. Okay, in the meantime, let's start with 81, and you can select the next one. So theta equals 1/3. There is no need to write radians, as I mentioned. The area equals 2 square feet. and they're asking us to find the radius. Okay. So we know that the formula is area equals 1/2 r squared theta. This is very nice. It's in radians. This is given to us as 2, and we have to find r. No problem. Nothing needs to be converted. So 2 equals 1/2 times r squared times 1/3. What do we do? What will be the first step here towards solving for r?
Multiply by 3.
Yes, actually by 6. 12 equals r squared. Good. And now, what operation we need to perform? What type of equation is this? How do we continue? And
Take the square root.
yes, of course. Theoretically, I should write plus or minus to the square root of 3, to be exact. Of course not. There is no need, because we are talking about a radius. So then I will write to the square root of 3, and I have to write the measurement unit. It has to be feet. If you want to approximate, you will approximate as 2 multiplied by 1.73. And we get 3.46 feet. Any questions on how to find the radius of a circular sector with an area of 2 square feet, and that subtends that opening, if you want, that theta equals 1/3 of a radian?
Wait. Can you explain how we got 3.46 feet? How did we go from 2.137?
This is this.
Oh, okay.
Any questions? Now, one of the things that I would like you to remember is that 1 radian is approximately 57 degrees. How do I know? Okay, from here. Pi equals 180 degrees. 1 radian equals 180 over pi. When I divide 180 by pi, 180 divided by pi right here, 57.3. It's good to remember this. Roughly 57 degrees. 1 radian is roughly 57 degrees. Okay, so let's go back. I'm sharing here. So I also selected 89. We have an area that we need to determine. It says find the length and the area. Okay, so they're giving us a central angle of 70 degrees, and they're giving us the measure of the radius, which is 12. Would you like us to work on a problem like this?
Yes.
And find the length and the area. Okay, so 89. So I'm going to graph. So this is 70 degrees, and the radius is 12 yards. And they want us to find the area, and they want us to find the arc length. I have to say to myself, stop, 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 because I have to change the degrees into radians. The formula is S equals R times theta. I have R, but I don't have theta in the correct format. And A equals 1/2 R squared times theta. I have the radius, 12 squared, 1/2 in front, but I do not have theta in radians yet. No problem. 70 degrees. Remember, if you forgot, pi equals 180 degrees. 1 degree is pi over 180. So 70 will be 70 times pi over 180. Maybe I should just put an arrow. And I have 7 pi over 18. So this is 7 pi over 18. This is 7 pi over 18. And then I can put them in the formula and it's done, in which R is 12. So I will be able to find S in yards and the area in yards squared, or squared yards. Please remember the measurement units. I'm begging you, please never forget measurement units. Okay. Okay, I'm on page 9. So in this case, S equals R, which is 12, times this. A equals 1/2. 12 squared is 144 times 7 pi over 18. If you want to simplify, we simplify. If you want to approximate, we can approximate directly with the calculator. What does it say? Let's take a look. I did not read that. Pardon? Round answers to 3 decimal places. Okay, so all they want is us to plug it in. Fine. Good. So careful how you plug it in. So we have 12, and we have times 7 times pi. Here is pi right here. With the second feature, the second key, and pi. And we divide by 18. They want 3 decimal places. Okay, so then S equals 14.661 because they want 3 decimal places, yards. 3 decimal places, 1, 2, 3. But because this 4th digit is 5 or more, I have to increase the 0 to 1. The other one, 144. Careful how you do this. 144 times 7 times pi. And now you have to divide. You either put it in parentheses 2 times 18 or you divide by 36. But do not divide by 2 and then multiply by 18 without parentheses because it's going to give you a totally different answer. So they want 3 decimal digits, the same thing. I'm looking at the 3rd one, but the 4th one is 5 or more. So I have to increase the 4 to 5. So the area is 87.965, and it has to be in squared yards because it's area. How are we doing with these 2 formulas? Do we need more examples, or can we go to the word problem?
Can I get another example, please?
Yes. Here they are. Oh, I'm lying to you. Sorry, here they are. We did 81 and we did 89. I don't know why I selected 83. Let's see. It's up to you. You can choose any problem. And then we'll look at the word problem.
82.
82. Very good. So let's look at 82. What does 82 say? 82 has theta equals 1/4. It has the area as 6 squared centimeters. Good. And we're asked to determine the radius. Okay. Good. So everything is nice and clean. Radians, I don't need to worry about anything. So I just write the formula A equals 1/2 r squared theta. And I just plug everything in that I have. So I have 6, I have 1/2, I don't have r, and I have 1/4. Good? What now? What do I need to do next? To solve this equation, I have to
Multiply by 8.
exactly 4 times 2. So r squared equals 48, like we did before. We have to take the square root. I should write plus or minus. This is 16 times 3. But then I will cross it out, not a mistake. And I will say only for the square root of 3. And if you want to approximate it, you'll have 4 times 1.73, and you approximate that. I have to write the measurement unit. So it's centimeters. Good pick. Any questions? So we can complete this section with, where is that problem? Right here, here it is. So it says in problems 107, 110, so we're looking at 108. They are showing us the Earth, the equator. They are showing us a central angle, and they're giving us the, as you see here, the radius of Earth is right here, 3960 miles. So from this point to the center, or this point from the center, so any point to the center of the Earth, the distance was determined as being 3,960 miles. And they're showing us on, it's basically a sphere, they're pretty much. So they're showing us this angle. And now they're telling us that we are looking at the distance between Charleston, West Virginia, and Jackson, Florida. They're giving us the position of these two cities. They're telling us that Charleston is at the north latitude, northern part of northern hemisphere, in other words, at 38 degrees and 21 minutes. And Jacksonville is further south towards the equator at 30 degrees and 20 minutes. Still north latitude, because that's where we are. Okay? Assume that the radius of Earth is 3,960 miles. Find the distance. This may not be the driving distance, right? It's just the distance between the two cities and their positions on Earth. Okay, so let me copy that information. So this is 108, and we have Charleston, and that is 38 degrees 21 minutes, and Jacksonville is at 30 and 20 minutes. And they're giving us the radius as 3960 miles. Okay. So here's the situation. Okay, page 10. So we have 3960 miles here. We need to determine this angle in order to find the distance. So once I find theta, I know that S will be radius times theta. So 3960 times theta. But I cannot find the distance before I find theta. Okay. So 38 degrees and 21 minutes minus 30 degrees and 20 minutes is, from the northern part, we subtract the southern part, latitude. So this is basically 8 degrees and 01 minutes. But I cannot put this in here. I have to change it into radians. So this angle is clearly 8 degrees and a little bit. But I have to change it into radians to put in the formula. The formula requires theta to be in radians. The formula does not work if theta is not in radians. How do I change this into radians? Okay, perfect. I have two pieces to worry about. So one thing that I would like to remind you is that 1 degree equals 60 minutes. So the 8 degrees will be very easy to change into radians. That's no problem. But I also have to worry about the minutes. there is 1 minute here. Well, 8 degrees and 1 minute represents 8 plus 1 divided by 60. And you can say, wait a minute, wait, where does this come from? Very simple. If 1 degree corresponds to 60 minutes, what will 1 minute correspond to in degrees? Minutes under minutes, degrees under degrees. One more time. If 1 degree corresponds to 60 minutes, what will to how many degrees will 1 minute correspond? This is a very nice proportion. 1 over x equals 60 over 1. And when we talked about proportions, remember I showed you that tiny trick. Can you cross multiply and divide? Of course. But this is so much easier. So x equals 1 over 60. So now I have 8 plus 1 over 60. That's no big deal. 60 times 8, 480 plus 1, 481 over 60. So I added these two to change everything into degrees, so that now I can change it into radians. So first I needed to calculate how many degrees is 8 degrees and 1 minute, because I can't have 2 measurement units. And I have to change degrees into radians. So I added the 8 degrees, this tiny little piece that I just found out, that 1 minute, you can do, I showed you this because this is too easy for 1, right? But this works, this method works for anything. If you want to find, for example, 4 minutes, how many degrees will be 4 minutes? How many will be 10 minutes? And this formula works very nicely to find out anything. Yes, basically you are divided by 60, but I just wanted to see where it's coming from. Okay, so now I have this in degrees. So now the formula will be S equals 3960 times degrees changed into radians. You can say, I forgot. How do I change 1 degree into radian? Okay, pi equals 180. So I want degrees into radians. So I'll multiply by pi over 180. You never have to memorize that. I'm not saying not to memorize anything. I'm just saying if you want 1 degree, because we have the degrees, and we have to multiply by what 1 degree represents, is pi over 180. Now I have to be very careful how I plug this in the graphing calculator. So let's do that. So here it is.